You press the button, the door drops a few inches, and then it jerks back toward the ceiling while the overhead lights flash. Most homeowners see this as the moment the overhead motor finally died, and they start bracing for a heavy repair bill. Modern garage doors operate as integrated safety networks, mandated by federal law, UL 325. UL 325 is the safety standard that requires all residential garage door openers to include primary entrapment protection, such as sensors that stop a closing door if an object is detected. When the system reverses, it is broadcasting a diagnostic status through a sequence of blinks, beeps, and mechanical feedback. Identifying these specific feedback patterns allows you to resolve obstructed sensors, drifting travel limits, and power failures with basic tools like a microfiber cloth and a screwdriver. The first layer of telemetry is visual. On the motor housing, you may see the up and down arrows flashing in a one-up, one-down sequence, or the main lights blinking 4 times. This points to the photo eye safety sensors. They maintain a continuous binary handshake across the garage using an invisible infrared beam. If dust, a cobweb, or a slight physical tilt severs this connection, the logic board triggers a reversal and displays the error code. To fix this, you wipe the lenses clean and pivot the mounting brackets until the green emitting LED and the amber receiving LED both show a steady, solid glow. Once that infrared path is restored, the logic board's safety mandate is satisfied and the door is permitted to close. Sometimes the sensors are perfectly clear, but the door still reverses as soon as it touches the ground, flagging a 4-1 or 1-6 excessive force error. While the electric motor is the most visible part of the system, it is designed to guide the door panels rather than lift them. Lifting is done by torsion springs, heavy coils above the door storing energy to counterbalance the door's weight. Over time, track friction causes the travel limits to drift, altering the machine's digital memory of where the floor is located. You reset this by using the adjustment buttons to manually move the door to its proper open and closed positions, teaching the motor the correct range of motion. Recalibrating these limits ensures the motor doesn't mistake a collision with the floor for a dangerous obstruction. The system also uses auditory signals, such as a sharp beep that sounds exactly every 30 seconds. This 30-second interval indicates that the internal emergency backup battery has failed and needs to be replaced. For digital connectivity, a smart hub flashing blue and green LEDs means it is disconnected from the home's Wi-Fi network. 2.4 GHz is a wireless frequency band that provides the long-range penetration needed to reach through garage walls. Identifying these specific alarms allows you to isolate networking and battery issues from physical mechanical failures. By following these diagnostic cues, you can solve sensor misalignments, reset spatial limits, and restore network connections without guesswork. However, there is a clear limit to what these adjustments can fix. Telemetry cannot resolve major structural failures. If you see a frayed lifting cable or a torsion spring that has snapped, you are looking at a system under dangerous levels of tension. If the motor continues to struggle and throw codes after the sensors are cleaned and limits are reset, the machine is warning you of a critical loss of physical counterbalance. Interpreting these diagnostics allows you to handle the software and sensor tweaks that cause most daily issues, while identifying the specific mechanical dangers that require a professional.